I'll be showing how to find the intercepts and axis of symmetry for a two-variable equation. So in this example, we have y squared equals x plus 4. We're going to start off with finding the intercepts. So an intercept is when either the line or quadratic or whatever you have on your function intercepts the x or the y axis. So when it intercepts the y-axis, x is always 0, and when it intercepts the x-axis, y is always 0. So knowing this, when we have an equation like this, if we set x or y to 0, then that gives us our intercept. So we're going to start with solving for y over here. We're going to solve for y by setting x to 0. So y squared equals x plus 4. X is 0, so 0 plus 4, y squared equals 4. Because you basically just remove x. So if we take the square root of y, we get y equals plus or minus 2. It's plus or minus 2 because you can have negative 2 squared or positive 2 squared, and it will still equal 4. So this gives us our two y-intercepts, because when x is 0, y is equal to either plus or minus 2. And we get two solutions because it's the square root. So 0, 2, or 0, negative 2 is our two intercepts. So let's plot that real quick just for reference later on. So 0, 1, 2, that's our negative. 1, 2, that's our positive. And note how they're equal distance from the origin. That'll be important later. So next we want to find our x-intercepts. So we find our x-intercepts when y is equal to 0. So y squared equals x plus 4. Y squared is 0, so 0 equals x plus 4. Minus 4 on both sides to get x by itself. X equals negative 4. And because y is 0, then the solution for the intercept is negative 4, 0. So if we go 1, 2, 3, 4 in the negative direction, that's our x. And then then because it's a function, we fill in, so it looks something like this. And it's going this way because y is squared. Sort of like if it was quadratic x was squared, it'd be going up or down. But because it's y, it's moving on the x axis. So on the earlier note of them being equal distance from the center, they're both 2 away, right? And basically what it means by symmetry is if you can take one of the axes and fold it over, it will give you the same function. So if we fold it over the x-axis, then this line will be the same one over here. It will be mirrored. However, if we try to flip it over the y-axis, then we get negative 4 here. It curved like this. We can see the left and the right side would not be the same. Unlike where if we flipped it from the x, they would be the same. The points would line up perfectly. So in Pearson, we're going to input our intercepts. So that's just these three pairs. When inputting it, it's important to get your spacing right so it can recognize the answer is correct. 0. I haven't found the order of the pairs to be important quite yet, though. But you want to make sure the space between the numbers and after the pairs, and use the comma. The only time there would be no intercepts is if you had like an asymptote or something, but we do not. Nice work. Alright, the next question relates to what I said earlier. Is the graph of the equation symmetric to the x-axis? Well, if we take the x-axis, can we fold the function over and would it be the same? Would it be mirrored? Yes, it would be, because this point lines up perfectly with that one. Yes. Would it be symmetric to the y-axis? Well, if we take this point and move it to over here, is this the same function? No, because they're not overlapping perfectly. It's not mirrored. No, it would not be. And then, is the graph symmetric to respect of the origin? So what it means by in respect to the origin is if, let's say, we have another function here. This was our origin, right? If we had a function that looks like this, then you could fold it, you could flip it, mirror it over the origin, the center point, or over this line. If we fold it over, again, just like flipping over the y-axis, it looked really weird, and it would not give us a symmetrical function. It would not be the same. So no, it is not symmetric to the origin. And that is how you find the intercepts and axis symmetry for a two-variable equation.